All right, let's get started, everyone. So, can you all hear me back there? I assume this is fine. I don't have to use a mic. All right. So this is the spring 2022 iteration of Advanced NLP, CS685. And yeah, for today, I just want to go over some administrative things, and then after we're done with that, give you a brief overview of the field, what we're going to cover this semester, and finally at the end we'll go through a bunch of demos of various cutting-edge NLP systems, just to give you an idea of what these things are currently capable of and what limitations they have. And we'll be discussing how to build these things throughout the rest of the semester. All right, so let's start with some logistics. So as you know from the Piazza, how many of you are on Piazza? Okay, I tried to enroll everyone. I assume that worked. This is a hybrid class, so you can feel free to follow along either on YouTube. So currently there are 15 people on YouTube, and I guess like 40-ish people here, and this class has 115 enrolled people, so I'm not sure what the remaining half of the class is doing. Probably trying to find this room. But anyway, every lecture will be streamed live on YouTube, so you can choose whether you want to come over here or watch it live. The streams are recorded and posted afterwards, so you don't have to watch it at this time. You can watch it whenever you want. There's not this week, but usually most weeks there will be a kind of quiz that is released on Monday and will be due the Friday of that week on Gradescope. I am still working on setting up Gradescope, so you'll all be on it sometime later this week. So these quizzes are usually 1 to 2 questions, normally 2 questions. We do not grade them for correctness, but we do at least check to see that you've made an honest effort to answer the problem. Some of them are quite open-ended. They're meant to get you to think about the topics for the week. And we will be using Gradescope for all assignment submissions, not only this quiz. All right, so we have 2 TAs for this class. They're Andrew Drozdov and Shufan Wang. They're both my own PhD students. Their research is in NLP, so they're experts in this field. You should feel free to ask them any question that you might ask me. And they will be guiding some of you on your final projects as well. So all of us will have office hours every week that I'll talk about in a bit. If you are interested throughout the course of this class in learning more about the NLP research that's being done at UMass, because we have many NLP faculty other than myself and many students working on this, you can check out the nlp.cs.umass.edu website for some news and information. Okay, so the course has a single email. If you have any sort of queries about anything course related, please email this account. If you email me, I'm probably not going to respond because I get a ton of email and I already don't respond to it. And there's also the course website, which you should follow along with for links to homework, deadlines, readings, and so on. We also put reminders about these things on Piazza as well, but the course website will be updated regularly. So, for instance, today, if I click this, if you go to the schedule, there's a link to the video, there's a link to these slides that I'm currently presenting. So these slides will be posted before the start of every class. And you can feel free to, if you like to take notes on the slides or whatever, feel free to do that during the class. Okay, so office hours. My office hours will be held always in person, and I also open Zoom in like while I'm in person. So if you want to talk to me via Zoom, you can do that. I tried this last semester, and it was honestly pretty hard to, if there are a lot of people in person, to also keep track of the Zoom. So I'll try my best, but it's kind of hard. The TAs, however, will. So currently Andrew is remote, so his office hours for the beginning of the semester will be held entirely over Zoom, and Shufan's will be held in person. Then they'll switch in the middle of the semester. So you will always have a Zoom option and an in-person option for TA office hours. So we have one exam in this class. Sometimes we extend our office hours if people have a lot of questions during them. The homeworks, last semester we didn't have a need to extend the office hours, but who knows, maybe this week, this semester, the homeworks will be more difficult. It's TBD. So there will be no office hours this week. You will have your first office hours starting next Tuesday with Andrew's office hours if you need those. All right. Yeah, I'm not sure about how many people are on the wait list or override or whatever, but don't email any of us about this. We don't know any of the details. If you have any questions regarding this, email Jess Kadarsman, and she can help you out with these requests. The add drop deadline for both grads and undergrads is February 7th to drop without any record of this class on your whatever. So keep that in mind. Okay, looks like we have some interesting Russian or something. I don't know. Does anyone know what language this is in? Anyway, this comment seems to be irrelevant. Yes, so I should mention that if you are a legitimate student watching this on YouTube, you should feel free to ask any questions you have in the chat box, and I do respond to them whenever I see them. So yeah, that will be your way to interact with the class. Okay, so we also have many different ways for you to give us feedback. If you don't want to use Piazza, there's an anonymous Google form where people like to post things that might be too private for a public forum, or post suggestions on topics to cover, or if they thought the grading was unfair or whatever. I mean, I guess students also post that on Piazza, but so if there are any responses, we'll go over them at the start of every class. So some questions from last semester were, does this course require prior knowledge of NLP? The answer to that is no. We will teach you all the NLP you need to know. But having some fundamental knowledge in probability, stats, calculus, Python programming, and machine learning will be helpful. So this is a project-oriented class. There will be a couple of homework assignments, there will be one exam, and then there's a final project. Those are, other than those short weekly quizzes, those are all of the things that you have to do. And the project is are generally a pretty heavy implementation component of this class. So we expect you to do a lot of coding and model training and evaluating different things that you've built and so on. So because this is a large class and we can't give feedback to a ton of different groups, we have a minimum project group, minimum and maximum project group size of 4. So you're gonna have to form groups of 4 people, work together with your group to complete your project. Yeah, and we have slides posted before the lecture. Sometimes when we're doing like derivations or explaining the equations behind particular models, I will write on an iPad and then I will post the thing that I wrote on the iPad after class. So you can follow along during class, and I'll also post my notes after class. All right, any questions so far? Should feel free to interrupt me. Okay. So like I was saying, there's no official prerequisites for this class, but it'll be very useful if you know, I'm sure most, if not all of you, are able to program in Python. We will primarily be using PyTorch in this class to implement the various models that we'll be discussing. We'll go through, like a lot of the stuff we will learn depends on some basic knowledge of probability, linear algebra, like matrix, vector, multiplication, and so on, and calculus as well. So you should be able to take derivatives of things. Pretty much that's all you need. And you should be excited, at least at some level, about language and having computers try and understand and generate language. So we won't go through like basic probability or anything like that. So if you think you're lacking in any of these areas, you should brush up on your own time on whatever it is that you need. Okay, so the grading breakdown. So I mentioned these weekly quizzes. You'll have maybe 8 to 10 of these over the semester. They will make up 10% of your grade. So these are basically, there's no, I mean, of course, if you have a medical issue or something, you can send detail of why you need an extension or something to the instructor's account. But otherwise, if you just forget to do one, you will just not get any credit for that quiz. So that's 10% of your grade. Then depending on how many homeworks we have, the homework component will be either 20 or 30%. Last semester, we failed to have more than 2 homeworks, so it was 20%. This semester, we may have 3 homeworks. It kind of depends on how much material we've gotten through at certain points in the semester. The homeworks, each homework is a combination of both a written part and a programming part. They're all going to be done on Google Colab. So Google Colab allows you to have part of a GPU to train and evaluate neural network models. So you're not going to need to have any sort of GPU access yourself. We'll be using Google Colab for everything. So far, Google Colab has worked great for the last 2 years, but hopefully it continues to work. They seem to be getting more and more restrictive as to how much memory you can get on a GPU. Okay, I see a question. What's the grade scope and roll code? I haven't actually made the grade scope yet, so I'll enroll all of you automatically once I do that later this week. Okay, so aside from the problem sets, you will also have an exam. This is usually in early March, so it's not a final exam, it's more of like a midterm, I guess. And we'll go with the same logistics setup that we've gone with for the previous 2 semesters of this class, where the exam will be completely open book and open internet. You can use whatever resources you want. You have 24 hours to complete it and turn it in on Gradescope. So this exam is meant to test your conceptual understanding of the different things that we cover over the semester. It's generally pretty difficult. Last semester, the average was in the 70s, which is a little higher than expected. The previous semester, it was in the high 50s, which was lower, so around there. It is quite challenging. We will give you practice midterms from previous semesters and go over all the answers the week before the exam, so you'll be somewhat prepared. And you'll know what kinds of questions to expect. Finally, you have your final projects. And again, this is in groups of 4 unless you have a valid reason for an exception. Some of those reasons include if you are a PhD student at UMass currently working on some project involving NLP, we generally give you an exception so you can use your thesis research for this course project. Otherwise, it's generally you have to form a group. We let you choose whatever topic you want, as long as it obviously involves text and building models or something in some way. And there's only 2 deliverables. So there's a project proposal, which will be in mid-February. It'll be due. And then there's a final report. So there's no, I mean, it depends on how the COVID situation goes, but last semester we had no presentation component. I feel like this semester we won't have one either. But the report is a large portion of your grade. And again, the breakdown here kind of depends on how many homework assignments we have. So if we have 3 homeworks, we will reduce the weighting of the final project. All right, any questions about grades? Okay. As far as readings go, there's no need to buy any textbooks. We will provide readings as PDFs on the website. They're usually going to be NLP conference papers or journal papers or some notes. But the early on readings will come from a freely available NLP textbook. So, yeah. Okay, so there are 2 semesters now of publicly available videos and materials, notes, and everything for this class already available. So there's, if you go to this link, you can see the fall 2020 offering, and this one has the fall 2021 offering. Both of them have links to videos and slides. This course will have a lot of overlap with the fall 2021 offering. So if you wanted to get ahead of the material in this class, you can feel free to look at those for ideas or whatever. There will be some new stuff, new topics that will be covered this semester that won't be covered in the previous 2 semesters. Maybe 1 or 2 new topics, but yeah, I debated whether or not I should just make you watch these old videos, and then thought that would be boring for both me and you. So yeah, many of the topics will be identical, however. All right, so we have a question. What are the grade boundaries? Are they fixed, or would it depend on the class performance? Yeah, so it generally depends on the class performance, but in both of the previous 2 offerings of the class, we had, I think, a 90 be the cutoff between an A and an A minus, and an 85 be the cutoff between a A minus and a B plus. And yeah, most of the class does fairly well. I think the majority of students get either an A minus or an A. Of course, that is not a guarantee that you will all get A minuses or A's. So please don't think that that's what I mean. That's just the historic trend. All right. Okay, any final logistics questions before we do some introduction about the topic itself? So there's a question about extra credit. Yeah, usually there's some form of extra credit. Sometimes it's been listen to this lecture by someone else and write a short report on it. Last semester we had an extra credit assignment, which was kind of like a homework. But yeah, there's usually some extra credit which can give you like 1 or 2 points on top of your final grade. I'm not sure yet what form that will take this semester. Other questions? All right. Oh, okay.
Are you going to teach this class fall 2022?
Fall 2022. I'm hoping not to have to teach in fall 2022, but it's still, currently I'm not planning to. All right. Okay, so we have one question on YouTube. Can the group size exceed 4? No. So the group size should be 4. And so to facilitate the forming the groups, we usually have a Piazza thread where people post like they're looking for teammates for some sort of idea. Other people will join based on that. And I'll talk more about this towards the end of the slides. Okay, so let's get to the topic of the day, which is natural language processing. So the types of languages that we'll be talking about in this class are languages that evolved naturally through human use for the purpose of communication, right? So we are not talking about things like Klingon, although they're very interesting in their own right. And we're not, as of now, going to be talking about programming languages, although interestingly, there have been recent developments using technology built for language understanding and generation and applying them to generate things like code or comments for code. So we may have one lecture about those things, and some of you might have seen the Codex model that you can now integrate into like Visual Studio or VS Code, which is really cool. Yeah, we might talk about that, but that's not our focus of the semester. We'll spend the vast majority of the semester talking about natural languages and how to understand them. So what exactly does processing mean? I mean, there are many different things that a computer can do given natural language. One of the most common things is trying to map some piece of input text to some external set of labels or something like that that you've already provided your computer with. So for example, I might take a review off of Amazon and ask a computer, predict what score this person gave this review. So these kinds of problems fall under the umbrella of supervised learning, where generally I have a large labeled data set. So maybe I have thousands of existing Amazon reviews paired with their scores, and the model can learn from this how to predict, maybe when I see great product, this should get a higher score than if I see horrible product, right? So you can also do more exploratory things. Like, for example, maybe you don't know what you want to get out of your text corpus. You just have a bunch of text and you want to know, for example, what topics are frequently discussed in this data set. So here, if you don't actually know, what you want to get out of your data, you just want to kind of explore it, you might use unsupervised methods where a model is asked to do things like clustering to find, text that is similar to each other in this data set, or extract actual topics like word lists that kind of give you an idea of maybe this document is talking about sports or this document is talking about politics or something like that. And a lot of this class will focus on generating text. So given some context, it could be other text, like write a story about this character or so on, or it could be an image, right? Write a caption about this image. It could be many different things, but the goal of the model is to take this information into consideration and condition its predictions of what words it wants to generate on the context that it receives. And we'll see in this semester how this formulation of generating text can actually be used to solve a bunch of different NLP problems, including things like determining an Amazon review's sentiment. So this is one of the more recent developments in NLP. Why are languages like Klingon excluded here? Are there differences between Klingon and English that change what techniques should be applied to when working with them? I'm not super familiar with Klingon, but it is a constructed language, so I imagine it's maybe more formulaic than something like English. There are also really no resources developed for Klingon NLP resources that I know of, although that'd be very interesting. So, I mean, if you wanted to do a project on making such things for Klingon, I probably would be okay with that. But yeah, I mean, a lot of the stuff on constructed languages, the interesting things are how do you actually construct a language? Like, for example, the Game of Thrones language, what is it called? Yeah, Dothraki. I actually went to a talk with the guy who created that language, and he was, it's like a very involved process to make an entire language, as you can imagine. And he was mad because like such a small portion of this giant language that he created was actually used in the show itself. But yes, we're not going to be working with Klingon. Okay, nice question. All right, so let's move on. There are some basic levels of linguistic structure that we'll be talking about throughout this semester. So if we take this sentence, Alice talked to Bob, at the very basic level, we can split this sentence into a bunch of characters, right? A-L-I-C-E, and this is how we spell different words. So moving beyond characters, we can see that certain combinations of characters occur quite frequently, right? So we can move to this subword level. We can talk about things like morphology, where the suffix ed indicates that this is in the past tense, right? So this is a meaningful combination of characters. Similarly, the stem talk carries some semantic meaning about what this verb actually means, right? Like, so of course we can go beyond subwords to actual words. So here we have 5 different words. Alice talked to Bob. Each of them is conveying some sort of meaning, and then when you compose all of these words together, you get the meaning of the full sentence. And so then that process of composition is a function of both syntax as well as semantics. So when we talk about syntax, we're talking about things like the grammar of the language, the different rules that allow you to compose different words together into a full sentence. So here, maybe the most low-level type of syntax is a part of speech. So every word has a part of speech. Here we have something like, talked is a verb in the past tense, to is a preposition, period is a punctuation, and so on. But we also have different types of syntax, like higher-level tree-like structures of sentences, right? So here, if we take talked to Bob, we can see that this phrase here forms a VP, a verb phrase, talked to Bob, where talked is the verb part of this verb phrase. To Bob is a prepositional phrase. You combine the prepositional phrase with the verb to form a verb phrase, and you can combine this verb phrase with a noun phrase to form a sentence at the root node. So one of the lectures in this class will talk about how do you actually get these tree-like structures given a sentence. So there are some cool algorithms that have been developed many years ago to do this task of parsing, it's called. All right, and then finally at the highest level, when you have your full sentence, you have the semantics of that sentence and also discourse properties. So how does this sentence interact with other sentences to form some sort of longer narrative? So here, if we had some sort of explicit meaning representation, we might say that Alice is the agent of this sentence, of this action of talking, this communication event. She's the one doing the talking. Bob is the recipient of this action, right? He's the one receiving the knowledge from Alice. Throughout this semester, we'll be looking at models that operate at the lowest level, that take in a sequence of characters, or even lower level than that, a sequence of bytes, and produce representations of sentences, paragraphs, and documents. We'll be looking at subword models, word models. We'll be looking at syntactic parses of sentences, and we'll be looking at different semantic representations. So this slide kind of covers the different levels of linguistic structure that we will look at throughout this class. Will this class involve linguistic content? So many of the tasks that we talk about here are linguistically motivated. For example, producing a parse of a sentence based on some grammatical rules. but you are definitely not expected to have a linguistics background to take this class or understand any of the applications. Most of the things that we're going to be talking about have practical, real-world applications to different for different end users. So, for example, like sentiment classification. The goal here is you can imagine many different motivations for why you would want to build something like this. Like Amazon might want to see if someone, is always, or maybe someone's scores differ from the content of their review, or someone's writing fake reviews, or something like that. So the motivation here doesn't always come from linguistics, but in some cases it does. Okay, so let's talk a little bit more about different applications, just continuing that thread. So supervised learning, as I mentioned before, is when you're given some collection of already labeled text, say documents. So if you have each example is a document called X, and it comes with a label Y. So maybe this is a review text, and then the label is positive or negative, right? Something like that. Then you want to train a model that maps from just the input text to this label. And you want to apply this model to new documents that you don't already have labeled, of course, because why would you ever apply it to a document that you already have the label for? So some tasks that are commonly tackled in this supervised setting include sentiment analysis. That's been like the example I've used to this point. Question answering. So you might have a document and want to ask questions about that document, right? Or you might have a huge collection of documents like Wikipedia, and you want to ask a question about anything in Wikipedia. So you might have a QA task that returns a span of text from this huge collection of documents that answers the question. Or you might have a model that, given a question and some collection of documents, generates an answer to the question. There are other tasks like textual entailment. So given two sentences, can a model tell whether the first sentence contradicts the second one? And, very important practical task, machine translation, right? So given a sentence in one language, translate it to another language. So we'll learn about, the underlying models behind systems like Google Translate and how they're trained, how you collect data for these things, and how you build the models. Okay, so an important distinction to make is that there's a kind of subclass of supervised learning that's closer to unsupervised learning, and it's been given this name of self-supervised learning. This is one of the most important types of, in both natural language processing and now also in computer vision, methods for learning just general properties about text. So here you're given just a large collection of text without any labels. And the reason why it's called self-supervised is that you have an automatic process that creates labels out of this huge collection of text, and then a model is trained over this data. So as an example of a self-supervised task, we have language modeling, which we will spend probably the majority of the semester talking about language models, conditional language models, and different types of applications that use language models. Basically, you're given the beginning of a sentence or a document, and your model is asked to predict the next word, the word that occurs immediately after this prefix of the document. So why would you consider this a self-supervised task rather than, say, a supervised task like sentiment analysis? Right, so I don't need to collect labels for this task, right? So let's consider sentiment analysis. I have a review. I need someone to tell me what the score of that review is before I can actually build a model, right? So there's some outside person, like the author of the review, who is associating a score with the text that they just wrote. In language modeling, the task is the labels come directly from the text, right? I can take any document, just split it at some point, and then ask a model to predict the next word, right? And I can do this given, there's so much text on the internet. I can basically get, hundreds of thousands of terabytes of data to train my model for free, right? So I still have labels. They're the next word, but no one has given me those labels. I get them for free from the data itself. So this is considered a self-supervised training objective, and it's really allowed this field to scale up to huge classes of models and data sets that can do very interesting things, as we'll see later on in the lecture. So there are different variants of language modeling that people have proposed. One that's particularly common is masked language modeling. So this is a little different than language modeling in that here, you're not just given a prefix of a document, you're given the entire document, but one span of text or one word or some words are masked out. So they're just blanked out, and a model is asked to fill in those missing words or spans. So you can see here, just like in language modeling, we get the data for free. We can choose any word or span of words to mask out and tell the model to predict these things. And so why might this be a useful thing to train a model on? So if you think about it, let's just say I'm given this span of text, like, I don't know, Alice went to the blank, and I ask the model to predict what comes next. So a model has to know a lot of different things in order to make a reasonable prediction about what goes in this blank, right? It has to know, for example, that if you have this prepositional phrase to the, it's probably some sort of location that comes next, right? So there's some semantic constraints on what can come next. There's some syntactic constraints, right? I can't just predict like the word the again. That doesn't make sense. That's not grammatical. So similarly, there's so many different things that a model needs to know in order to make this prediction, right? Maybe I have some sentences before this one that say more things about Alice and what her motivations are that put further constraints on where she could be going in this sentence. So the general idea here is that this task of language modeling requires a model to learn, to achieve at least some sort of basic understanding of linguistic properties that are generally useful for solving many different tasks. That's the general idea. So our next lecture on Monday will focus on this task of language modeling and some simple count-based models to solve it. Later on in the next couple of weeks, we will quickly shift over to neural network language models, and those will form the backbone for basically the rest of the semester. Okay, so representation learning is not a distinct thing from all of these other categories, but it is something that we'll be talking about quite a bit. And so, especially within the context of neural network models of language, basically the idea is that given some text, our goal might be to create a low-dimensional representation of that text that we can then use to solve some sort of downstream task. So we would like this representation to capture some of these linguistic properties that we've talked about, like semantics, syntax, and discourse. So we will commonly look at representation learning where the representations are vectors. So these are real-valued, low-dimensional vectors. For example, we might represent the word today with this 4-dimensional vector of just numbers. And you would hope that words that are similar to today, so maybe like tomorrow or yesterday, occur in the same rough space of this vector space as today does. And maybe cat occurs in the vector space near things like dog or animal or something like that. So we can expand this intuition to phrases, to sentences, to even to documents. We can represent all of these things with vectors or other objects, but we'll focus on vectors. And then we can manipulate these vectors to, this is basically how these models learn. They're manipulating different vector representations of text to solve a particular task. So if that's confusing, that's fine. We will go into this in a lot more detail over the next couple of lectures. Okay, can we create models to create new languages using self-supervised learning just by using some rules? I'm not an expert on creating new languages, so I'm not really sure how that's done or whether a model can do it. I assume you could write a bunch of rules to convert like some existing language to a new one, but it might not be a good new language. This is very similar to the Klingon question. I feel like I should have more expertise on Klingon to answer something like this, but maybe you can figure it out and post on Piazza. Okay, so yeah, any questions so far? Okay. So transfer learning is another type of, another paradigm that we will spend a lot of time focusing on. So I've already explained how self-supervised models like language models are very useful for learning general linguistic properties of a text. But we might want to take a language model that knows all of these properties and kind of repurpose it to solve a single task that we care about, or a small set of tasks that we care about. So if I wanted to solve sentiment analysis, right? This is the task of, given some text, predict the sentiment of that text, like whether it's positive or negative about something. So if I wanted to solve this, the simple, most straightforward way is to take some labeled data set, like I could crawl Amazon reviews or Yelp reviews, and train a model directly on that. The problem is those data sets are always going to be much, much smaller and more limited than the data that I can get for a self-supervised task, like language modeling. For language modeling, you can basically assume you have infinite data. Like you could crawl the entire internet and get free data for predicting the next word, right? So I can learn a lot more about language from language modeling than I can from a small set of like Yelp reviews. So I may want to transfer the knowledge that I learned from this task of language modeling into a model that can do sentiment analysis. And so this is this transfer learning paradigm where, let's say I have some huge scale language model that I trained to predict the next word, and I want it to also do this task of sentiment analysis. So I can use a process called fine-tuning to kind of specialize this huge language model into solving the task that I care about, sentiment analysis. So this paradigm of transfer learning has become basically the method of choice for solving most NLP tasks over the last 3 or 4 years. So we'll spend quite a bit of time talking about this, and you'll have one assignment playing around with different transfer learning scenarios as well. Okay, so rough list of topics. As it's become probably pretty clear from this overview, language models are super important. So the next lecture will focus on this task and some simple methods. Then we'll start talking about some neural network models of language. Then in doing so, we will also go over some of the basics of training neural networks, doing backpropagation, things that many of you might have seen before in other classes, but I assume is also new to some of you. So we'll go through it, and we'll go through also basic things you need to know for these models, like gradient descent and how exactly you should optimize them and so on. Then we'll cover a set of models. We'll look at feed-forward neural networks, recurrent neural networks, and we will then get to transformers, which are basically the current state-of-the-art architecture for natural language processing. It's a type of neural network that is able to process fairly efficiently long sequences of text. We look at variants of transformers then that are more efficient in different ways or have other properties that are nice for text processing. We will look at specific instantiations of all of these architectures that have been developed and introduced over the years. So there is a class of Muppet named models, Elmo and Bert, and there's many others like Ernie and Kermit, and basically every Muppet has been used at this point. So we'll go through what those things are. We'll also talk about some of the huge scale language models. We'll see some of these in the demo towards the end of the class. And once we're all done with that, we'll start talking about specific tasks. So we'll look a lot at text generation tasks because these can kind of subsume many other NLP tasks like classification and sequence labeling and so on. We'll look specifically, we'll have lectures for translation, maybe even 2 lectures on that, and how these things interface with information retrieval as well. So there's been an increasing convergence between these 2 fields. Then we'll look at how do you actually get data to train these different models, what kind of curation is necessary, how do you collect labels for your data set, how do you avoid artifacts, and how do you evaluate models that are doing fairly complicated tasks like answering complicated questions or generating stories or things like that. There's obviously a lot of ethical issues that arise when you're training models on the internet, as all of you can imagine being familiar with the internet. There are many different types of bias that are pervasive across web scale data, and even other types of data as well. So we look at methods for measuring this and kind of countering it. There's also privacy issues, right? So if you train your language model on customer data and then you deploy a product that uses this model, you don't want it leaking any information about your customers, right? So there's different methods you can use to get around some of these things. And we talk a lot about some of these methods. So some of the newest developments which are interesting and have come out in the last year or so are prompt-based learning. So we'll look at some of that in detail. It's okay if you don't understand what that is now. As I mentioned before, variants of the transformer architecture that have nice properties. There's recently been a lot of work on multilingual models that can, like a single model that can process hundreds of different languages and solve many different tasks, which are really cool. So we'll look at that. And we'll also spend some time on language and vision, the intersection between those 2 things. There have been some nice new models there that people can play around with. All right, any questions about the topic list so far? Okay, so I'm going to switch gears now and talk about the final projects in more detail because you'll have to form your groups pretty soon, I think by the end of next week, by February 7th, whatever day that is. So we will start that Piazza thread this week so people can figure out their groups. Of course, you might not care what group you're in, and so if you haven't submitted the group form, which will also be released this week, basically there's a Google form and you just fill in like who your teammates are and so on. If you do not form a group by yourself, then we will randomly assign you to a group on February 7th and put you in contact with all of the group members that you were assigned to. So if you want to choose your group, you have that option. Otherwise, we will put you in a group randomly. Like I said before, there are 2 deliverables, and the first one is coming up on February 18th. So it's a project proposal. It should be at least 3 pages long, and we know that at this point you probably will not have understood many of the concepts that you might want to use in the future to solve whatever task it is that you propose. But so we don't expect you to have a clear idea of what methods you're going to use to solve the task that you propose, or how exactly you're going to complete this project. But we found that it's very useful to do this project proposal as early as possible, so the rest of the semester, using the things that you learn along the way, you can just start working on it and have a lot more time to do a good job, rather than if it's all just shoved at the end of the semester. So for the project proposal, we'll give every group some fairly in-depth feedback on how feasible the idea is and what methods they might want to use for solving this project, or what analysis might be required, how to evaluate. All of those things you should hint at in your project proposals. There's a template for both the proposal and report that we will give out that we expect you to follow. And in some cases, your idea might not be feasible or might not make sense, and we will tell you and ask you to choose a different idea for your final project. So these projects are almost completely open-ended. They've all got to involve natural language data in some way, and they should include at least some amount of model implementation. So nowadays with NLP, there are a lot of libraries, as we'll see, that give you access to a bunch of models, and you can easily go from 0 to like a model for sentiment analysis in like 5 lines of code. Maybe that's an exaggeration, but it's not too far off. So this is not sufficient for a final project. We expect you to actually do some implementation of at least one model on the data or task that you have proposed. And we expect everyone to submit their code as well for the final report, so we can actually see what you've done. Yeah, so any questions about the project? Yes?
Yeah, can we get like any suggestions for like that year's project, just ideas?
Yeah, so we'll talk a little bit later about some ideas of specific projects, and yeah, I also will post project reports from the previous semesters. I just have to get student permission before I do that, but yeah, I will do that. Yes? The question is, oh, that's another thing. For the YouTube people, I need to remember to repeat the questions or you can't hear them. I forgot that over and over again last semester. But okay, the question is, does the scope of natural language include voice or speech data? So the methods for doing things like speech recognition are quite different than the ones used for text. Also, some of the like the data is very different if you're dealing with like waveforms rather than text. So if you are going from speech to text and then you're doing some processing on top of that, that's fine. But if you're just sticking to speech, then I mean, speech to text is fine as well. But if there are other things you're doing, like I don't know, emotion detection from speech, that's probably outside the scope of the project. Other questions?
Could we use a pre-trained model, like embedding or features from that, and then train our model?
Yes. Yes. So the question is, can we use a pre-trained model and then train our own models on top of that? That's totally fine, as long as you are writing the code to do that latter step. And frankly, we expect you to do things like that because you all will not have access to resources, like computational resources, to train huge-scale pre-trained models yourselves. So if you want your project to work to some extent, you will probably need to rely on pre-trained models. Yeah. I should also mention that the compute for these final projects, most groups use Google Colab. Some groups have had success with, I think Google Colab Pro is not that expensive and you get better resources. You are not to use the UMass GPU cluster for this project. That's intended strictly for research purposes, and if they find you, the admins find class project, any sort of class-related stuff going on, they'll remove your account. So most of you probably don't have accounts on this because you're only supposed to get it if you're doing research. But if you do, you're not allowed to use your account for course-related stuff. All right, how innovative should the project be? Are we allowed to make projects on areas with considerable work already present? Yeah, so I mean, it's good to have a creative new idea, but we don't expect you to do something completely new. You're definitely allowed to work on things that have prior work available. And you could do like an analysis of existing work. You could do things like that as long as it's in depth. But yeah, we don't expect you to like propose a completely new model or task. That's outside the expectations for a class project. Okay, so your project in short could either build an NLP system or model, or take a bunch of existing models and apply them to solve a new task that they haven't already been applied on. You could also, if you're more interested in the data aspect, you could create your own data set and then report results on it from a bunch of different baseline models. Just remember in this case that we do expect you to implement one of those models yourselves, even if there are existing implementations available. All right, so yeah, we'll talk a little bit more about this in later classes, but we basically want you to, when you're thinking about a proposal, the very first thing you should do once you have an idea is figure out what's been done before, what are the existing resources and methods that have been proposed, and then what experiments are you interested in doing, and how will you know whether they worked. So you should feel free to be ambitious in your proposals at least. We will tell you if what you proposed is not going to work or is infeasible or whatever. And importantly, your project does not have to work in order for you to get a good grade. Your grades are based mostly on like whether all of the things you tried or did were reasonable and whether you put a good amount of effort into the project. So if you say, you're gonna make a state-of-the-art sentiment analysis model, you're probably not gonna do that, first of all. And even if you fall well short of the state-of-the-art, you could still have implemented many different interesting ideas and then analyzed why they don't work as well, and that would be sufficient. Okay, so to figure out what's been done before, most NLP publications are open access. The top conferences, ACL, EMNLP, and NACL are all publicly available, so you can look at them on the ACL Anthology website, which is linked here. There's also NLP-related work that appears in machine learning conferences and AI, information retrieval conferences. You can use Google Scholar or Semantic Scholar to see which papers in your area are most impactful. Like you could look at the number of citations, for example, which can correlate to how impactful a paper has been. You can look at web pages of authors or professors who have written papers on topics that you're interested in to find more related stuff and so on. So in your proposal, again, we're going to give you a template that basically has all of these different fields that you'll have to fill out. What is your problem? Why should we care? What has been done before? What data are you going to explore this problem on? How are you going to evaluate it? And what kinds of resources do you need to solve this problem? What libraries will you be using? And so on. So this slide has a ton of different examples, and like I mentioned, we'll post some sample project reports as well and proposals. there's a bunch of different tasks that people find interesting. So this slide has just a subset of those things. Like I said, you might want to just survey the papers from the last conference or something like that. And the homework, so there's going to be a homework 0. It's like a review of basic math and stuff. It will also force you to pick one paper that was published at a recent conference and write a short summary of this. So you'll get some experience in reading these things. All right. So I'm just going to skip over a lot of this. You can look at the slides for some of these tools. I wanted to save some time for the demos at the end here. But yes, this homework that I mentioned will be released tomorrow. It's due February 4th. All the deadlines are at 11:59 p.m. Eastern Time on the date that they're due, and you should submit them as PDFs on Gradescope. The readings for next Monday will be posted later this week. There will be a textbook chapter on language models, and you have your final project deadlines to keep in mind. Okay, so let's go to some demos, which might give you a better idea of some tasks that you can consider. So over the past couple of years, this startup called Hugging Face that some of you might have heard of has done a great job at making models that are accessible to just anyone. So here there are 26,900 NLP models that people have trained up and then uploaded to Hugging Face, and anyone can use them very easily through this library. So it's a really great resource. You can see that there's a bunch of different tasks over here, and if you click on one of them, so let's say we click text classification, there are many different models that have been trained to do different text classification tasks that you could look at. So if you're looking for something for your proposal, let's say you're interested in sentiment classification, you can go here. So this group, Cardiff NLP, has trained a sentiment analysis model on Twitter data. So they trained this on 58 million tweets, which is quite a lot. And so they have and a nice thing about Hugging Face is that they have these live little demo things here. So you can type in any sentence, presumably, and get sentiment. So I like you, I love you. This is probably positive sentiment. If you hit compute, oh, they didn't label there. Okay, so it says 0 is negative, 1 is neutral, and 2 is positive. So this one put 98% probability on positive. Does anyone want to give a sentence? All right, let's try. This movie was horrible. So this should be quite easy. Okay, so it says 98% negative. Anyone want to try?
I like you, but
okay. I like you, but okay. Anyone want to fill in this? But I'm okay. Not sure what to expect here. I mean, it did a pretty good job overall. I think neutral is maybe right. So we can try a different. Is this readable for people in the back? No? Faintly. All right. What about now? All right. Let's try a different task. Okay, hang on. Maybe we can try summarization. So Facebook has released this summarization model where you can put in any document and it will give you a summary of it. So let's see how this looks. So this document here is about the Eiffel Tower becoming the tallest building. It's basically about the Eiffel Tower. So if we hit compute, I mean, this was just a cached document. So it says the tower is there. I mean, it's short. let's try it on, so I could just copy this text here and try it, I guess. Why don't I try that? So this text here is just describing this model, what data it was tuned on, and so on. Let's see if it can, oh, it copied it with the formatting. I hope that doesn't break it. BART model pre-trained on English language and fine-tuned. BART is a transformer. It's not that bad. I think it probably just selected like a few sentences from this. And okay, so anyway, like you can try out a bunch of different models on this Hugging Face platform, and you know, in addition to looking through actual papers, you can also look for, once you find a task you're interested in, look for an actual model that supports that task so you can maybe start building off of that. We'll also have a homework assignment actually a couple homework assignments that use this library so you can get a sense of how to, once you get one of these models, how to actually fine-tune it to do some other task or different things using this library. Okay, let's see if there's any YouTube questions. Message retracted, all right. So I also wanted to show another demo before the class ends. So there's a company called OpenAI, that a nonprofit that many of you might have heard of. They recently, maybe like a year and a half ago, released a really huge scale language model called GPT-3. Which now I think is publicly available for anyone to access. Before it was only released to like a small number of people, but the model is really huge, so they don't release the parameters of their model so that you can, fine-tune it. Instead, they have an API that you can use to query their huge model and get completions of some text that you send. So I'm not sure what these newer ones are, but I'll just switch over to their. So this is a good demonstration of language modeling, the task. I can put in, even that sentence that I was writing about here, and then ask it. So now I'm asking it to produce, say, 198 words after that follow this prefix. Alice went to the. Maybe it's not working. Oh. Alice went to the table and laid the pen down. Wow, this is seems like a pretty compelling introduction to a story. Yeah, so this so it's hard to say. You could imagine maybe this model, because it was trained on the Common Crawl, which is just a dump of a huge chunk of the internet. Maybe it saw a document that began with Alice went to the, and it just memorized what came after that, and that's what it's produced here. Does anyone want to give me a prefix that probably would never have occurred before, so we can see if it is really memorizing this or it's doing something smarter?
Is it possible that it has seen the COVID-19?
Oh, that's a good question. It might have been trained before COVID-19. Okay, so we could write something about COVID-19. Anyone have a sentence or something?
The pandemic of COVID-19 has been
devastating. When will it end? How about that? Let's see what it says. Oh my god, this is so bad. Wow, it's not wrong. Okay, so yeah, see, it didn't memorize this unless. Yeah, this is like a because I put in a question, right? So it is like an interview. That's interesting. But you could also imagine, maybe there was another disease or illness that had the same sort of template, and then it just replaced whatever the name of that disease was with COVID-19, right? It's very hard to know what this model is doing because you don't know what is in the internet. People have written everything, so yes.
I guess maybe a reason it might not be just regurgitating is it says that there are other pandemic viruses out there, but none of them are as dangerous as COVID-19. Even so, there are some that are just as dangerous, but that will likely like anyone would.
Right, that doesn't even make sense, right? It's just like directly contradicts what it said in the. Yeah, so you'll notice, and we'll talk about this more, that as these models generate more and more text, they become increasingly less coherent. And like this is a kind of subtle example. Sometimes they'll just start to repeat what they've already said over and over again. Yeah, so we'll talk about different methods to fix that. But yeah, I agree, that's definitely one misleading thing. So maybe we can try asking it something about this class, since it hasn't seen that. I think I did that last semester and it was pretty good. The average grade in CS685 in the spring semester will be. All right. Based on this, I will determine all of your grades. Oh. Wow, what is going on? I could generate my whole syllabus using this. All right, so let's end here. And on Monday, we will talk about language models. So I'll post some readings then.